Assalamu alaikum. My name is Sayyid Muhammad Kazim Rizvi and my registration number is 23TE89. I'm going to present my assignment on breadth first search BFS and depth first search DFS. These are the two fundamental search algorithms in artificial intelligence. These algorithms are used to explore graphs, trees to find solution efficiently. If you see the BFS, we will work by level, while in DFS, we explore depth first before backtracking, in which the recursion process is take. In breadth first search, we will have queues, while in depth first search, which is the stack. Breadth first search has the FIFO method, in which first in, first out, while in the depth first search, we will have LIFO, in which last in and first out. So in this assignment, I have implemented both algorithm and demonstrated them using tree diagrams, graph traversal, robotic graph navigation, real world application, and Python code, which we have uh, in the last task. These are my main five basic tasks. So I will explain each task one by one to you. So here is the first task, in which a tree diagram is given for both BFS and DFS. We will see the mm, we will apply BFS, which uses a queue data structure FIFO, in which first in first out method is applied. So if we go, let's say, choose here. So we will start from visiting 0, and then add their children's like 1, 2, 3. So start from here and then here to 2 and then 3. So this is our first step. And in the second step, if we directly visit 0 from 1, let's say we are already here, then we will visit 2, and the children of 1 is 4 and 5. So we will add 4 and 5 to this. After that, we are already at 2. We will visit 2 and its children is 6, this one. And then we will move to the 3. Then we will add 7 because its children is 7. So we will visit something like this zigzag method, step by step, 0 from 0 to 1, 1 to 2, 3, 4, 5, 6, 7. As we have also the output here, 0, 1, 2, 3, 4, 5, 6, 7. So from here we can say that BFS uh, explores all nodes at the same level before going deeper. Now if we see the DFS, which uses the stack or recursion, which is called LIFO method, last in first out, it goes as deep as before backtracking. So it also follow the recursion method by, let's say, we can go from 0 to 1 and also from 1 to 0. But we will first tell you about the overall process, in which we will go from one point to the end, like 0 to 1, 1 to 4, and then 4 to 5, and then 2, and then 6, and then 3, and then 7. So here it is written 0 to 1, and then 4, and 5, and 2, and 6, and 3, and 7. So this follows this path, like this, and this. So it will go deep and deep before the backtracking. Then we have given the outputs here: BFS using queue, DFS depth-wise using stacks or recursion. And these are the steps which we have followed by visiting first 0. I have told in the above part that visiting 0 and then 1 and then 2 and then 3. So these are the steps which I have already told you. So visit 0 and queue is 0, then remove 0, go to 1, 2, 3, and this is the queue output is 0. And after that remove 1, we will go to the 4, but before that we have to add the childrens of 1, so which are 4 and 5. We will have in queue 2, 3, 4, 5. Output will be 0 and 1. And in step 4 we will go to the remove 2 and visit the 2. So just like this, I'll show you again. Sorry, just removing the part 2. So yeah, like this. 0, then visit 1, then remove 1 after visiting it, then go to 2. So from here we have added 4 and 5. From when we are at 2, we have added 6. When we are at 3, we have added 7. And we will follow this path. So the final output is here 0, 1, 2, 3, 4, 5, 6, 7. And the BFS explanation is that I have told you before. Same as for DSF, like starting from 0, root 0, go to the visit the first, visit 4, and visit 5. Same as the above which I have told, 0, 1, 4, 5, 2, 6, 3, 7. These are the outputs. So I have little less time, so I'm explaining very deep. I have to cover it in 3 minutes. So yeah. So our second task is graph diagram, which is given, which is the same as the above this diagram, tree diagram. Here it is given in the graph form, which is for breadth first search and depth first search, just like the above. From this to this to this, and so on. And for the depth first search, here to here, here, and here, and here, and here. Here is the example given. Not example, I mean the output or the order 0, 1, 2, 3, 4, 5, 6 for BFS, and for DFS we have 0, 1, 3, 4, and then 2, and then 5, and then 6. Moving forward, these are the LIFO and the FIFO I have told about. The third part is the robot grid. This is very important in this assignment. So we have a grid representation here as double zero x 0 which are the s is the start, g is the goal, and x are the obstacle, 0 is the free path. So it can only move in the free path from here to here and here, and also from here to straight here. So we will see here the shortest path for BFS. From S it can go from here to here and then here, also from here to straight here. So we have written here that column 0, row 0. Column 0, row 0, yes, S start from here, go down from S to column 0, row 1, this, and then go down column 0, row 2, this, and then move forward column 1, row 2, column 1, row 2, and then again column 2 and row 2. So this is 2 and 2. I have written 1 and 3, which is incorrect. So I will change it in the 2 and 2, and then final the G. So for the depth first search exploration, we have the same as we have followed here. but in this we will use the recursion method, so it can go forward and backward in both directions. From S we will go down, down, S, down, down. After that, right, 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 and right after we will get the G. So here are some differences between the BFS and GFS. First difference is about the strategy, which is level by level. For BFS and for DFS, it is depth first. Data structure, it is BFS, for it is queue. DFS, it is stack. Shortest path, BFS, yes. DFS, not guaranteed because it can use the recursion method and follow a long path. Memory usage is high in BFS and low in DFS. So our fourth task is the real world application in which BFS use the web crawling method. Web crawling process is automatically browsing and collecting information from websites and internet using special programs called web crawling or bots. So it explores websites by level, starting from a page and visiting all the links first. We have a diagram here in which it is shown properly. So this help in finding closest and most relevant pages quickly. So yeah, and for the other real world example, it's maze solving, which is for the DFS. So we use DFS to explore one path deeply until it finds the exit or dead end. Like by using DFS, it is good for exploring depth paths quickly. So for this, we will use DFS. This is same like we have the QR code in which the same path is followed and there is DFS is applied. So our last task is the Python code, which we have given some data like 2, 3, 4, 5, 6, 7, and we have implemented BFS and DFS using Python. So for the BFS function, we uses a queue from collection collections dot dq in this part, and in the second part we have selected uh, visit nodes. After that we have selected the call function. Here it should be. So let me do it clearly. Yeah, so in the BFS part, we have written a code in which we have defined the BFS graph starting visited sets by the queues in which every queue is visited one by one. So for that, it is easy to initialize the queue by visiting queue, add neighbors, and repeat. So it will help ensures nodes are visited level by level. And in DFS, is implemented by using recursion, so it can follow the both paths. It is easy, so we can visit nodes, call function or neighbors because it follows deep first traversal using recursion call. It is easy to solve a complicated complicated path such as this one, maze solving, like these. Go from here to here by using the recursion method. And in the end, we have our output of these data. So 1, 2, 3, 4, 5, 6, and 1, 2, 4, 5, 3, 6, 7. So let me go to the first example. We have done this from 0 to 1. 1 to 2, 2 to 3, 3 to 4, 5, 6, 7. So output is 0, 1, 2, 3, 4, 5, 6, 7 by visiting every queue one by one. And for DFS using recursion, 0 to 1, 1 to 4, 4 to 5, 5 to 2, 2 to 6, 6 to 3, 6 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. This is the output of BFS, and this is the output of DFS, which is same for the code output. 1, 2, 3, 4, 5, 6, 1, 2, 4, 5, 3, 6, 7. So it's all from my assignment. Sorry for taking too much time because I was a little confused about the code because I have written something that is not here. So yeah, thanks.